We're going to look at steps 2 and 3, reabsorption and secretion in urine formation. Step 2 of urine formation is reabsorption. During glomerular filtration, we're not selective as far as what gets filtered out of the plasma. So we do filter out the waste products, but we're also filtering out a lot of good things as well. So things like glucose, amino acids, vitamins, and water. So these are things that we want to reabsorb from the filtrate and put it back into the blood. So we're going to reabsorb 99% of the filtrate, and we only end up producing about 1 to 2 liters of urine per day. Reabsorption occurs in the renal tubules, and 65%, the majority of reabsorption, is going to occur in the proximal convoluted tubule. Here's a picture of reabsorption. We're going to be reabsorbing the things we want to save from the filtrate or the urine and put them back into the blood and the peritubular capillaries. The majority of reabsorption, 65%, will occur in the proximal convoluted tubule, so right after the glomerulus. This is just a table just showing you the percentage of substances that are reabsorbed. So you can see water, we're going to reabsorb most of that, 99%. Glucose is very valuable. We use that as a fuel source to make ATP, and so we're going to reabsorb 100% of that. Some other things like urea is a waste product. We actually do end up reabsorbing about half of that. And we'll take a look at what some of that urea is actually used for later. And then we do reabsorb a lot of the electrolytes too, so these ions. There are 2 pathways that are used to reabsorb substances from the filtrate and put it back into the blood and the peritubular capillaries. There's the transcellular route and paracellular transport. Let's take a look at the proximal convoluted tubule. The wall of the proximal convoluted tubule is made up of epithelial cells. They have an apical membrane, which is going to face the lumen, or where the urine or filtrate is. And then the basolateral membrane is going to face the blood. The transcellular route, trans means across. We're just going to be transporting things right across these epithelial cells and then into the peritubular capillaries. If the substance is hydrophilic, we will need to use transport proteins to get them across the membrane. Paracellular transport, we have these tight junctions in between the epithelial cells, but the tight junctions are not really tight. They're actually leaky, so that's very different than normal tight junctions. So we have leaky tight junctions, and with paracellular transport, things can move in between the cells through those leaky tight junctions, and they get reabsorbed back into the blood. Reabsorption can happen through passive diffusion, osmosis, or active transport. With passive diffusion, remember that substances are going to move from high to low concentration, and if we're transporting a hydrophilic substance across the transcellular route, we will need some transport proteins there. Water from the filtrate will be reabsorbed into the blood and the peritubular capillaries through osmosis. So if you're reabsorbing solutes, remember that water likes to follow the solutes. So water will just diffuse down its concentration gradient and follow the solutes into the blood. Active transport can also be used to reabsorb hydrophilic substances. So remember, in active transport, we're going to move substances against the concentration gradient, going from low to high concentration. And either primary or secondary active transport can be used. And that can occur either on the basolateral membrane or the apical membrane. With the reabsorption of hydrophilic substances, transport proteins are used. And remember that transport proteins can become saturated. So you reach a point where you can't reabsorb any more of that solute. So this is called the renal threshold. The renal threshold is just the plasma concentration of a solute, at which spillover into the urine occurs, which means you can't reabsorb any more of that solute and it remains in the urine. A great example of this is diabetes mellitus, where the blood glucose is too high. We're going to end up filtering more into the urine. We usually reabsorb 100% of the glucose, but because we've got more glucose than normal in the urine, we can't reabsorb all of it because those transport proteins become saturated. So some of the glucose stays in the urine and is excreted, and that's called glucoseuria. Step 3 of urine formation is secretion. This is where we take substances that are in the blood and the peritubular capillaries and put them back into the filtrate or the urine, and then we will excrete those and get rid of them. So we will use this for things like hydrogen ions, which will help us regulate blood pH. So if we're too acidic, we can take those hydrogen ions that are in the blood, we've got too many, put those into the urine and then urinate those out. We also secrete potassium ions, which we'll look at later with the hormone aldosterone. And then any waste products that maybe we didn't filter enough out in the glomerulus, we can secrete them from the blood into the urine. So things like creatinine and drugs will also be secreted.